Hello everyone, this is the second lecture of Engineering Economics. My name is Sandeep Yadav and I'm Prime Minister's Research Fellow at IIT Bombay. I am the teacher of that course. So today we are going to start a second lecture, that is a topic. We will cover two topics in that. First is the interest rate, what are the different interest rates that we are having, and the second is the time value of money. So let's start with an introduction. So in engineering, decision frequently involve evaluating the trade-offs among costs and benefits that occur at different times. That means in any engineering decision, we have to make a decision. Means what we have to lose and what we have to gain. Between like the gains that we are having is the benefits, and the things that we have to give, that is cost. So we have to compromise between the cost to get some benefit. So this will involve in any kind of engineering decision. A typical situation is when the investments are made in a project in order to obtain benefits from the project in future. In every project, we have to make some inputs before we are getting any output for that. For that, engineering economics plays a pivotal role in that, and we have to calculate with the different kind of interest rate. We have to make a present, we have to calculate the future worth with the present inputs that we are giving. Suppose you are investing in a company like 10 lakh rupees, and you are getting output after 5 years. So you are expecting the more than 10 lakhs because the value of money getting decreased after 5 years. That we will calculate with the different kinds of interest rates. Economic methods are used to compare benefits and costs that will occur at different times, that I will tell you in today's lecture how we have to calculate. The key to making these comparison is to use a interest rate. As I've already told you, for the basic things that we are going to use for the different comparison of present and future values, that these are interest rates. Now, there are two, majorly if we see, there are two kinds of interest rate, that are simple interest and compound interest. The term interest, interest period, and the rate of interest are useful in calculating equal sums of money for one interest period in the past and one period in the future. However, more than one interest period, the term simple interest and compound interest becomes important. So, if we have to calculate a thing that is bought today and we want to get the value of tomorrow or some after some time, then we have to calculate a we have to know what is the interest rate, and is it compounding or is it a simple interest rate. So let's start with the simple interest rate. Simple interest is calculated using present, using principal only, ignoring interest that occur in the preceding interest rate. So suppose you are getting a loan of 10,000 rupees for a period of 1 year. So now, if the interest is getting applied on the principal amount only, then we will not incur the interest of interest. That is a thing that is done in the compound interest thing. So the formula for the simple interest will be easy, like simple interest will be principal multiplied by the number of period, that is n, and multiplied by the interest rate. Interest rate will be always been from the 0 to 100%, and it will be in between a depending on the value. So we have to put this thing in a decimal. Like if the interest value is 20%, then we have to put a value like if this is given at 20%, then we have to write it as a 0.2. Okay, let's move on with an example. Suppose a financing company lent an engineering company 100,000 rupees, that is 1 lakh rupees, and the loan for 3 years at an interest rate of 10%, at a simple interest rate. So now we have to calculate how much money will firm. So now we have to calculate how much money will the firm repay at the end of 3 years. So let's look at the solution. So the solution will be the interest rate for the each of the 3 years. Suppose interest rates per year will be 1 lakh into 10%. That is for the first year the interest rate will be 10,000, and for the 3 years, because it is a simple interest rate, we can easily multiply by 3, and we can say the interest for 3 years will be 30,000. Now the amount due after 3 years, that means the company has got 1 lakh rupees, and then after 3 years the company have to return amount of principal amount plus interest, that is for 3 years, that is 1,30,000 rupees. Now the interest accrued in the first year and the second year does not earn interest. If we see in the compound investing interest that we will learn in the further slides, we will see the compound interest will have interest on that interest also. So now the interest due each year is 10,000 calculated only on the principal amount. So that's how simple interest works. Let's move on to the next slides. So now we will learn the compound interest. In most of the financial and economic analysis, we will use compound interest because simple interest is not that practically viable. So for in the practical purposes and for the each like all of the things that you will take any kind of loan or the for the home or education, the compound investing will work. So now the interest accrued for the each interest period is calculated on the principal plus total amount. Now you have to make things clear that in the compound interesting, the interest will be on principal plus total amount of interest accumulated on the all previous period. So thus the compound interest means interest on top of interest. Compound interest reflects the time value of money on the interest ratio also. Now now we can calculate the compound interest using the formula, that is compound interest will be principal plus all incurred interest into interest rate. So that is clear that compounding will be on the principal plus all interest. That will be calculated as a CI will be P plus 1 plus I into the power n, where n is the number of period, I is the interest rate, and P is the principal amount. Or we can calculate from this formula also. This will both will give a same result. In this we will calculate only interest, and this we will calculate the compound interest. Both the formula will give us the same result. Now let's take an example. Assume an engineering company borrows a 1 lakh rupees at 10% compound interest. It's the same question that we have solved for the simple interest. Now we will solve for the compound interest. For 10% compound interest, and will pay the principal after all the interest and after 3 years. Now we have to calculate the annual interest and the total amount due after 3 years. So let's see the solution. To include compounding of interest, the annual interest and the total owed each are calculated as interest for the year 1, that will be 1 lakh into interest rate, that will be 10,000 rupees. That will be for the first year. Now in the second year, total due will be for the year 1 will be 1 lakh rupees plus 10,000, that will be 1 lakh 10,000 rupees. This is equivalent to simple interest as we have calculated in the previous slides. Now from the year 2, the principal amount gets changed to the total amount due in a year 1, that is a plus principal plus interest rate for the first year. Now from the second year onwards, we have to multiply by 0.1, that is the interest rate, and the interest will come as a 11,000 rupees. So the total amount due will be principal plus interest, that will be 1,21,000. Similarly, in the year 3, we have to multiply by 0.1. Now the interest will come on the principal, that is the principal got changed to the year total amount due till year 2, that is 1,21,000 into multiplied by the interest rate. So now the interest we have to pay for the year 3rd will be 12,100 rupees. So the total amount due we can calculate as the principal plus interest, that will be 1,33,000. So that's when we are paying from the simple interest rate, we are getting only we are paying only 1,30,000. Now we have to pay more 3,000 extra. So that from the other formula we can also calculate that directly, that I've shown in the from this formula we can calculate directly 1 lakh multiplied by 1 plus 0.10 into to the power 3, that is the interest period, or we can say loan period. So then directly we can get 1,33,100 rupees. So this is all about simple and compound interest. If we will see in a graphical way, so this is the x-axis will have a interest rate, the annual amount owed, suppose the $1,000, and the x-axis, so this is the y-axis will have the amount owed, and the x-axis will have a years, like how much time period of the loan. So we can see from the year 0 there will be no interest. From the year 1 there will be interest I, year 2 interest will be I, year 3 interest will be I. So I is getting constant, and it is getting a arithmetic increase in a order. Means simply we are seeing that 1 lakh in, for the 1 lakh it is getting 1,10,000, 1,20,000, 1,30,000, 1,40,000. So if we will draw that on a graphical way, we are getting a arithmetic increase. While on a this is for the this is for a simple interest. Okay. Now if we have to calculate the same thing for the graph for the compound interest, then we can see for the compound interest the similar thing will be like interest will getting is getting changed. It is not constant as a 10% as it is in the no, sorry, it's not it's not getting a 10% as it is in simple interest, it's getting increased. So that interest rate is also increasing geometrically as well as the total amount owed. No, so this graph will show a geometric increase. So that way we can see graphically how interest rate changes. Now, if we will compound a simple interest and compound interest, calculate a simple and compound interest for the at a period at an interest rate of 24% per year for 20 years, we can see simple interest will having a gradual we will show a simple uh, straight line like arithmetic increase, and compound interest will show a geometric increase in the accumulated interest. So this shows a compound interest, this line shows a compound interest, and this shows a simple interest for the period of 20 years at an interest rate of 24%. So now we have seen graphically simple and compound interest. If we have to see a simple formula for simple interest, the formula will be 1 plus ni into p, and the compound interest, the formula will be 1 plus I to the power n into p. The compound interest allows the present or future values to be determined, and we can calculate, it can be inverted to give present value associated with the discount factor. If we will have a discount factor, then from the future value we can get a present value. There are some more type of interest, that is a nominal interest, or simple interest when the period is not 1 year. The nominal interest rate will be I into m, where m is the period of year. Also the effective interest, well, the compound interest when the period is not 1 year, then it will be I effective is equal to 1 plus r by m to the power m minus 1. Now if we are having a compounding, continuous compounding, then we can calculate with I effective is equal to exponential r minus 1, where r is the interest rate. So in that way, we can calculate nominal, effective, and continuous compounding. Now let's move on to the simple and compound interest tables. So as we see, this column shows the interest type, and this shows the typical formulas, and the whole table shows the time value of money interest formulas in a single payment. So this you can read for your reference. I have taken it from a book. You can directly get the put the values and calculate the different type of interest, like interest type, compound interest, nominal interest, effective for continuous compound interest. You can calculate. Here all the nomenclatures are given below. Now let's see the effect of different payment schedules. So suppose you are getting a loan for 5 years, and you are paying, you have 4 options, like plan 1. This column shows the end of year. This is the interest owed for the year. This column shows the total owed at the year end, and end of the year payment. And this shows the total amount after payment. Now this table shows the different repayment schedules over 5 years for $5,000 at an interest rate of 8% per year of compound interesting. Suppose you have 4 options. Option 1 is pay all at the end. Suppose you are getting $5,000 at an interest rate of 8%, and you have to pay finally after 5 years. Now for the initial 0th year, the total amount you owe is 5,000 rupees. For the now the from the year 1, you have to pay interest, that is 8% of 5,000 will be $400. Now the total amount you owe at the year 1 will be $5,400. That is the amount you owe. Similarly, if you will calculate for the year 2, 3, and 4, and 5, you have you can directly calculate the interest owed in the each year, and you can add up in the previous principal, and finally you have to owe the final amount, that is $7,346 approximately. So this is the amount you owe if you are paying at the end. Now let's see the other option, like pay interest annually. You have to pay interest annually, but the principal you can't pay. Means you are not able to pay, but you can pay the at least the interest rate. That is this. Now you can see the total amount owed at the year 0 will be 5,000. At the year 1, similarly from the at the pay at the end row, we can see that total amount owe after 1 year will be $5,400, and you can see that end of the year payment, you have made a 400 rupees of payment you have made. Now the total amount owed after payment will be remain only 5,000 rupees, because you have paid already the interest rate. Now for the year 2, the interest rate will be the same, because the principal is same. So now you are seeing the interest you are paying in annually is getting decreased, because you are paying interest each year. Your principal is getting constant, that is $5,000. Now the final amount you have to pay at the year 5 will be $7,000. That way you can save $346 if you pay interest annually. Now let's see plan 3. If you have to pay interest and a portion of principal annually, suppose at the year 0, you have got $5,000, and the interest will be calculated from the similar formula, that is $400, and the total amount owed at the year end will be $5,400, and the amount you will pay is 1,000 rupees from the principal, and $400 at the from the interest rate. So the amount you will pay is the $1,400. So the amount you owed after the payment will be 4,000 rupees. You paid and the year 2, if you will calculate the interest, that will be 4,000 into multiplied by 8%, that will be $320 only. Now the amount you owed will be $4,320, and you will pay out of that you will pay $1,320, and the remaining amount will be 3000. Similarly, in the year 3, 4, 5, you will pay. At the year 5, you will pay $1,080. The total amount, if you will calculate the add up all these, the total amount you will pay will be $6,200. So that will be the minimum among all if you will pay interest or and a portion of principal annually. Now let's see if there is a plan 4 which tells us we can pay equal annual amount of interest and principals. Now you have lent up $5,000 and the interest will be 400. That amount you owed will be 5,400, and you are paying equally $1,252 approximately, and the amount that interest is getting decreased as in the these both these plan 3 and plan 4 are quite similar, but in that way you have a liberty to choose how much amount you have to pay, and this tells us you have to pay equal amount. In this, all the interest is calculated initially, and the final amount you have to pay is minus $6,262. So these two will give us almost the same result, but the thing is only the liberty you have. So for some more details, if you want some this kind of comparison, you can refer that book. Now let's move. Let's solve a review problem to get some more clarity on the topic. Suppose you want to buy a new computer, but you are let's consider that $2 for the simplicity. Suppose you want to buy a new computer, but you are having 1,000 rupees short of the amount you need, and your aunt has agreed to lend you 1,000 rupees, but you need to now, provided you will pay $1,200. Let's do it with the dollar itself. So let's restart it. Suppose you want to buy a computer, but you are having $1,000 less than the amount of the PC computer, but your aunt agrees to pay you $1,000, but she tells you have to pay $1,200 after 2 years. So the period of interest will be 2 years, and the interest rate you can calculate with that we have to calculate. Now she compounds interest monthly. Now the period will be monthly, so we have a 24 periods. Now another place from which you can borrow 1,000 rupees from the bank also, you can get a loan. So there is a, however, loan processing fees of $20. Now the total amount will be $1,020, which will be included in the loan payment. So the bank is expecting to receive $1,220 2 years from the from now, based on the monthly compounding interest. So let's see what monthly rate is your aunt charging you for the loan. What is the bank charging? And the second thing we are going to calculate will be what effective annual rate is your aunt charging, and what is the bank charging. And finally, we have to make a decision. What would you prefer to borrow? Either you have to borrow from your aunt, or either you have to take a loan from the bank. So let's see. From the given things, like principal amount will be 1,000, final amount will be 1,200, and the period will be 24 months, since the compounding is done monthly. So from the formula, F is equal to P 1 plus I to power n, we can calculate directly. F will be like we can calculate interest rate. Interest rate will be 0.07626, and your aunt is charging interest rate will be 0.76% monthly. So now let's calculate for the bank. This is for the your aunt, and this is for the bank. Now the principal is 1,020, final amount will be 1,220, Interest period is the same. Now we can calculate the interest rate. Interest rate the bank is charging is 0.75%. So now you have calculated your aunt is charging more interest than the bank. So let's calculate the second thing. The second thing I ask is what is the effective annual rate. Let's see the effective annual rate can be found with a formula that is I've already explained you what is the effective formula rate. We can calculate the R is we can see that here R is the nominal rate, M is the number of compounding period, and since the number of compounding periods is per year is 12, we notice R by M is simply the interest rate charged per month. Now your aunt is charging 0.76 sorry 0.7626 percentage per month, and then we can calculate effective interest will be from this formula by putting values, that is 9.54%. Now let's calculate from the similar formula for the bank. We will see the bank effective annual rate from the bank will be 9.37%. So now we have calculated the effective annual interest rate annually, that is aunt is charging 9.54% and bank is charging 9.37% annually. Now let's see the what we have to choose. Now the bank appears to be charging a lower interest rate that offered by your aunt, that can be concluded by comparing the two monthly rates of effective annual rates. If you were to base your decision based only on the charge the lower interest rate, you will pick the bank, absolutely. But despite the fact that it has a fee, however, although you are borrowing 1020 from the bank, you are getting only $1000, since the bank immediately get $20 fee. Now the cost of money for you from the bank is better calculated as P will be the principal you're getting is 1000, and the amount you're getting is you have to pay is 12,020. Now let's see the pay for the period of, now the interest if you will calculate the effectively, now we can see from the point of view the bank is charging interest at a rate approximately 0.83 per month, and you would be prefer of borrowing from your aunt. So that's how the effective thing works. You have to prefer your aunt because she is charging 0.76% only, and the bank is effectively charging 0.083. So now we get some clarity. Now we can calculate to the now we can go to the next topic, that is present and future works. Let's see. Let's determine the present value of an investment or a payment in the future. You are due $10,000 signing bonus to be paid to you after you have completed 2 years of service with your new company. That's a typical package that company offer, that we will pay you like 2 lakh rupees or some amount of money after 2 years, but you have to calculate the future value for that. So what is the present value of that bonus, given that a 7% of interest rate that you can calculate? Now determine the future value of investment made today. Suppose you have invested $10,000 today for the period of 10 years at a 3 years per year compound interesting. So you can calculate simple similarly means you can calculate the present value and the future value from the formulas that have we have studied in the earlier slides. Now the present value of the retirement fund is $300,000. What will be worth when I'm getting 64 years old? So these all the formula questions you can answer by simply calculating the present and future values. Now let's see the time value of money. The basic problem we have to see how to determine value of cash flow that are expected in the future. Now, time value of money refers to the fact that a dollar in a hand today is worth more than a dollar promised at some time in a future, because the value of money is getting increase or decrease. Which would you rather have, $1,000 today or $1,000 in a 5 years? Obviously $1,000 today, because the value of money is getting decreased in 5 years because of some infl inflations and all the factors we have to consider. Now, money received sooner rather than later want to use the funds for investment or the consumption purpose. The concept is refers as a time value of money. Now we are coming to the directly to the topic, the time value of money. The time allows one opportunity to postpone consumption and earn the interest. Let's see the future compounding. Future values refers to the amount of money an investment will grow to over some length of time at a given interest rate. Means, to determine the future value in a single cash flow, we will need present value of that cash flow, interest rate, and time period. So now, future value we can calculate by present value multiplied by interest rate plus to the power n. Now, future value interest factors are is the interest rate and is the number of period. Now we will see the some example on the computation of the future value in the cash flow. Suppose you have invested 2,000 today in an account that pays you 6% of interest, which with the interest compound annually, how much will be in your account at the end of 2 years that are if there is no withdrawal in between. So in the zero time period, that is today, you have 2,000 rupees. After 1 year, you will have 6% increase of this to 2,000, and the year 2 you can calculate the final amount from the formulas. That will be around the principal plus interest rate. That will be, we can calculate 2,000 multiplied by 0.06, that is 120, plus 2,000 into 0.06, that will be, so finally the amount will be 2,247. So at the year 2 you will have a 2,247. Now let's see some another example. The future value formula. So the formula will be F1 will be future value will be present value multiplied by the interest rate for the number of periods. So the thing that we have calculated is the similarly like 2,247 rupees and some paisa. Now future value is equal to the value at some point in the future time. PV present a present value today, which is usually designated as a time 0. R is the interest rate, and N is the number of period of compounding. Now let's see an example. John wants to know how large his 5,000 deposit will become at the annual compound interest rate of 8% at the year 5. So at the year 0, we are John is having a 5,000 rupees, and it is getting an interest of 8% per annum. Now we have to calculate how much amount he will be having after 5 years. Similarly, with the formula, we can calculate this thing also, and that will be 7,346 rupees at the interest rate of 8% after 5 years. So now move on to the present value and the discounting. So the current value of future cash flows discounted at the appropriate discount rate over some length of time period. In that way, we can calculate the present value. And discounting is a process of translating a future value or set a future cash flow in a present value. So how can we calculate? To compute present value of in a single cash flow, we will need few things: future value of the cash flow, interest rate, time period. So the in the similar manner, from the formula of the future value, we can easily get this formula also. Present value will be future value divided by the 1 plus interest rate powered by time period, where the PV is the same. Now let's see this in a graphical manner. Just a minute. Example: assume that you will have you need to have 4,000 rupees saved in 10 years from now. How much must you deposit today in an account that pays a 6% of interest compound annually, so that you will reach a goal of 4,000 rupees? So this thing I'm explaining you in a personal way, but you have to think in a way that that engineering company or some industry needs to do that. They need some amount of 4 lakh rupees for 1 year of from now to expand their businesses and all. So this thing you have to think in a way, but I'm explaining you in from a personal point of view so that it will be easier to understand you. Now at the now we are having a future value. We have to calculate the present value. So the future value of 4,000 rupees at a discounting of 6% annually, we have to calculate a, here interest rate becomes a discount rate. Now let's see, 4,000 at the present value will be, from this formula we can calculate 4,000 divided by 1.06 powered by 10. So we have the present value of that 4,000 rupees will be 2,233 rupees. Now we can divide by 10 and get a yearly savings. How much amount we have to save? Now let's take an example. John needs to know how large of the deposit to make today, so that the money will grow 2,500 in a 5 years. Assume today the deposit will grow at a compound rate of 4% annually. So now we are having an interest rate and we are having a 2,500 rupees as a future value. We have to calculate a present value. Simply calculation based on the general formula that is given. We can calculate 2,500 divided by the interest rate powered by the time period. We will have 2,054 rupees. So let's move on to the next slide, that is the frequency of compounding. So what is the frequency of compounding? Frequency of compounding can be calculated from the formula future value will be equal to the present value multiplied by the 1 plus r by m powered by the m into n, where n is the number of years, m is the compounding period per year, r is the annual interest rate, FV will be the future value at the end of year end, and the PV will be the present value cash flow today. Now let's see an example. Suppose you have to deposit 1,000 in an account that pays you 12% interest compounded quarterly. Now the interest rate is compounding quarterly, means 4 times in a year. How much will be in the account after 8 years is there is no withdrawal? Let's see. Present value is 1,000. R will be 3% per quarter. Now the number of periods actually is 32 quarters at the interest rate of 3% per quarter. Now let's see, based on the formula, we will see the future value will be 2,575. Now we have seen the present and future values with the similar formulas and the compound interest annually or quarterly we have seen. So what we can do right now is that we can compare the present versus future values. So the present value factors are reciprocal to the future values. We can say interest rates and future values are positively related. Interest rate and present values are negatively related. As we can see from the formula itself, it's the reciprocal. So as the present value, uh, you can see from the formula itself. Now the time period and the future values are positively related, and the time period and the present values are negatively related. Now suppose all the things are given, we have to calculate the interest rate. At what interest rate should we invest our money today to get a desired amount of money after a certain number of years? Essentially, we are trying to determine the interest rate at a given present value, future value, and the time period. So now what we have to do? Let's see with an example. The rate which money can be doubled or tripled. An investment company want to invest some money which will give a and calculate how much amount how much time it will take to double its money or triple its money. Let's see for how long we have to invest money today to get a desired amount of money today at a given rate of interest. So now we have to calculate the rate of interest. Now we have to calculate the time period, at how much time period it will get doubled. Now determining the time period for which a current amount needs to be invested at a certain future value. Now in the previous period we are having an interest rate, we are having a time period, and we have to calculate a interest rate. In that thing we have a interest rate, we have to get a time period, at how much time period it will get double or tripled or whatever you want. Now example is the time period needed to double or triple period for a current investment. So what are the annuities? So annuities is a series of level, even, equal, or equal sized of cash flows that occur at the end of each time period for a fixed period of time. Example of annuities will be, suppose you're getting you're having a car loan, it's counted as an annuity. House, motorized insurance policies, you have to pay annually some amount of insurance, some lotteries, and retirement money, that will be treated as a annuities. Now let's move on to the example as a student loan. Suppose you have got a 10,000 in the August 2009, and bank collects the interest rate of 5% until the graduation on August 2013. So you have taken in, suppose I have done my engineering in 2000, started my engineering in 2009, and I've bought a loan from the bank at a 5% of interest rate, and I have to pay the start paying from the 2013. What amount do you need to pay upon your graduation? So we can calculate from the simple formula, from the compounding. I have to pay to 12,160 rupees. Let's take another example of annuity payments, that is a made series of single payments made at a fixed period of time. Example, installment loans, student loan period, mortgage, as I already explained. Assume a periodic compound interest and a payment at the first period. Discrete uniform series compound factor we have to calculate. Now the present worth of annuity we can calculate easily from that formula. Now we are getting more into the technical things. Now we have calculated for the personal, means how much amount we need to invest for getting X amount of future income. Now you are getting into the technical terms, that is a annuity, like how much amount you got from, suppose you are starting an industry, you got a loan of 10 lakh rupees, and you have to repay after 5 years. You have to calculate in that way. So let's move on. Let's see, as we have moved to technical terms, now let's take a technical example. Let's say compare two alternative pumps. Suppose you have started a company which uses a pump. So we have two options of pumps. First, a pump A, and second is a pump B. So the installation cost of that pump will be $20,000 and pump B will be the $25,000. That is a fixed cost. And yearly maintenance will be 4,000 rupees, and here it will be 3,000 rupees. It is a variable cost. Sorry, it's also a fixed cost. And service is 2 years and service is 3 years. As after 2 years of service and after 3 years service, it is having a some salvage value. Salvage value is some, or you can say some value of scrap, or you can say some like whatever you sell in some scrap or some scrappers, you will get a $500. Interest rate is 6.8%. Interest rate is the same, and the life of the plant is 6 years. So if you are choosing this pump, you have to replace 3 pumps, and if you are using this pump, you have to replace 2 pumps. Now let's see in how to solve. Determine the present value of each purpose, each sale of salvage equipment, all annual payments to for maintenance. Add them up, and finally we are getting a while adding, we have to see purchases are whatever purchase that we have made is treated as a negative value, and whatever sales we are getting out of that is treated as a positive. Now this is a calculation. These things are already given. Now calculation of present value of future purchases are negative, and sales are the sales of salvage are, of the equipment are the positive. So the first pump 20,000, for the second pump 25,000. That is the purchase prices at present value. Annual maintenance 19,000, that is 14,000. Second pump salvage value is 17,000 approximately, and that is 19,000. Third pump, because you have to change it, 3 pumps, salvage value will be 14,000. Now the total present value we have to invest is only on the pump is $17,931, and if you choose a pump B, we have to invest a 57,000. So it's better from this calculation that we have to choose a pump B for our operation, as it is giving us a net present value is lower. So this is the beauty of economic calculations, that you can that can save you a lot of money if you will calculate proper with some proper formula in an industry. So these are the reference books that you can get some more knowledge, or you want to get some more things. Otherwise, you can contact me also. I will tell you what are the next things. So we will meet in the next class. I will tell you what are the depreciation, and we will cover some more topics in that. Thank you.